All right, in solving one-step inequalities, let's first talk about some vocabulary words. A replacement set is the set of numbers we choose from to substitute in for the variable. The solution set is those numbers that make the statement true. In other words, we're looking for the answers here. Now, an inequality is a mathematical statement that contains either a less than sign, greater than, is less than or equal to, is greater than or equal to, or is not equal to. One of those inequality signs instead of an equal sign. To solve an inequality, follow the same steps as solving an equation. It's the exact same thing. I'm going to follow those same steps. Now, there is one exception, and I'll talk about that in just a few minutes. But let's talk about solving 3y minus 4 is greater than negative 37, and I get to use this, the integers from negative 13 to negative 9, as my replacement set. In other words, which of these numbers will make this inequality true? We're going to add 4 to both sides. We get 3y is greater than negative 33. When I divide both sides by 3, you get y is greater than negative 11. Which of these numbers is greater than negative 11, negative 10, and negative 9? In number 2, using the distributive property, I get 2w plus 8 is greater than or equal to 7w minus 7. My rule has always been to cancel, when you have variables on both sides, to cancel the variable on the right side. So I'm going to subtract 7w from both sides of the inequality. 2w minus 7w is negative 5w. Bring down the plus 8, greater than or equal to, and we have negative 7 left over on the right side. Subtracting 8 from both sides, we get negative 5w is greater than or equal to negative 15. Now at this point, I want to talk about the exception that we have. Let's come over here to the side, and we're going to leave this problem for just a moment, and we're going to talk about what happens when we divide both sides by negative 5. Let's say I have, negative 6 and positive 12. How does negative 6 compare to positive 12? Is it less than, greater than, equal to? It's less than, isn't it? And if I were to divide both sides by, say, 2, I would come up with negative 3 here. I'd come up with positive 6 here, and I still have negative 3 being less than 6. Let's try something else. Let's take that initial statement again. Negative 6 is less than 12. But this time, let's divide by negative 2 instead. Now, on the left side, negative 6 divided by negative 2 is positive 3. On the right side, 12 divided by 2 is negative 6. How does 3 compare to negative 6? It is greater than. So, what's the rule? The rule is when you divide both sides by a negative, or when you multiply both sides by a negative, you must reverse the inequality sign. So back to our problem in number 2. I'm going to divide both sides by -5. In doing that, I get W on the left side, I get 3 on the right side, but because I've divided by a negative, we must reverse the inequality sign, and we get W is less than or equal to 3. So which of these numbers is less than or equal to 3? 1, 2, and 3 would be my solution set. In the following problems, we're just simply going to solve for the variable indicated, and I'm going to subtract 9 from both sides. C is less than or equal to -6. Now, if I were to graph this on a number line, it would look like this. Let's say we have 0 over here, and -6 would be someplace to the left of it. Because this is less than or equal to, I would need to fill in a solid circle at -6, and I'm going to shade the number line everything to the left, because this is showing all the numbers that are less than or equal to -6. In number 2, whenever you have minus a negative, just make it a plus sign and rewrite it if you need to. H plus 7 is greater than -2. Subtracting 7 from both sides, I have H is greater than -9. Now, if we were going to graph this on a number line, it would look like this. Here's 0. -9 would be someplace to its left. Because it's just greater than, not equal to, it doesn't necessarily have to be equal to. It's not equal to. It's just greater than -9. It'll be a hollow circle at -9. And I'm going to shade everything to the right. Now notice that we're following the direction of the arrow, so to speak, when we go to shade. Back here, number 1, less than, it's pointing to the left, so we'll shade to the left. In number 2, it's pointing to the right, we're going to be shading to the right. And that only works when the variable is on the left side of the inequality sign. So in number 3, when we subtract 16 from both sides, we get W is less than -36. To graph that, let's say we had 0. -36 is somewhere to the left. It doesn't matter where you put it, just so long as it's to the left. It'll be a hollow circle at -36 because it's just less than, it's not equal to, and I'm going to shade everything to the left. Now notice on number 4 that the variable is on the right side. I still have to cancel out the -4. We do that by adding 4 to both sides of the inequality sign. -11 plus 4 is -7, is greater than D. But when I go to graph this on the number line, I need the variable on the left side so I can follow the direction of the arrow. So what I'm going to do is I'm going to take this inequality, and if I were to read this backwards, it would say D is less than -7. And I can write that with the variable on the left side by just writing D is less than -7. So if I had, let's do -9 this time and -7 here. -9 is to the left of -7. I have a hollow circle at -7. I'm going to shade everything in the direction of the arrow. I'm going to go shade to the left, and I have that. In number 5, subtract 1/3 from both sides. X is less than or equal to 5/12. If 0 is here and 1 is here, 5/12 would be, well, not quite halfway. It'll be a filled in circle at 5/12, and we're going to be shading to the left. Number 6, divide both sides by 7. N is greater than or equal to -7. If 0 is here, -7 will be to its left. It'll be a filled in circle, and we're going to be shading to the right. In number 7, oh, and by the way, on your paper, leave some space here, as we're going to be needing that space to write in a few other things in just a few minutes. All right, and number 7, notice that there is a negative 5 attached to the x. When there's a negative attached to that variable, we're going to be, in our last step, having to reverse the inequality sign. I'm dividing by a negative 5. What happens when you divide both sides by a negative? It reverses the inequality sign, so it'll be x is greater than positive 12. To graph that, if 0 is here, 12 is to its right somewhere, it'll be a hollow circle and shade to the right. In number 8, this fraction bar means divide. How do you cancel divide? By multiplying. So I'm going to multiply both sides by 3. The 3's cancel. We get w is greater than negative 36. Negative 36 would be to the left of 0. I'm going to have a hollow circle on negative 36 and shade to the right. Now, in number 9, we have negative 7/9 x is less than 42. Now, there are two ways we could solve for x here. We could divide both sides by negative 7/9. Plug 42 divided by negative 7/9 into your calculator and you'll get your answer. I would like to get you into the habit of not using division, dividing by a fraction. What I would like you to get in the habit of doing is multiplying by the reciprocal. Trust me, you'll like this later on when we do some more different types of problems, that if we multiply by the reciprocal, it will come out a lot nicer. So we're going to multiply both sides by negative 9/7. On the left side, we get our x. Why? Because the negatives cancel, leaving it to be a positive. The 9's cancel. The 7's cancel. You're left with x all by itself. That's what we were wanting. On the right side, we have 42 times negative 9/7. Plug that into your calculator and you'll get negative 54. But because we multiplied both sides by that negative number, that negative 9/7, we reverse the inequality sign. We get x is greater than negative 54. When we graph that, let's say I have 0 here and negative 54 here. Hollow circle at negative 54 and shade everything to the right. Now, the reason why I wanted you to leave a space here is because whenever you're solving story problems with inequality signs, you're going to run into certain phrases down the road. Things like is at least, is no less than, is at most, and is no more than. Is at least, what does that mean? It means the least something can be, which means it has to be greater than or equal to. Is no less than. Well, less than means the less than sign. No less than means it's greater than or equal to. The most something could be is at most. The most it can be is x. Well, what does that mean? It means less than or equal to. And same thing with is no more than. If it just said more than, that would be the greater than sign. But that's not what it says. It says no more than. It can't be more than. What can it be? Less than or equal to. So in number 1, when we have 3/5 of a number is at least negative 10, circle the phrase that gives you the inequality sign. Is at least is greater than or equal to negative 10. 3/5 of a number. Well, of means times, so we're going to have 3/5 times n is greater than or equal to negative 10. We could divide both sides by 3/5. I would much rather you multiply both sides by the reciprocal. we get n is greater than or equal to, and this you can just leave as an improper fraction, negative 50 over 3. Is less than is the less than sign. Something's less than 27. What is it? Well, it's a number increased by 11. N plus 11, subtracting 11 from both sides, n is less than 16. And lastly, is at most. The most something could be. Well, what does that mean? Well, is at most means less than or equal to. So we have less than or equal to 13. Well, the opposite of a number divided by 5. Well, if our number is n, the opposite of it would be negative n. Divided by 5 would just be a fraction bar over 5 is less than or equal to 13. To solve this, we need to cancel out the 5 and the negative, so I'm going to multiply both sides by negative 5. Multiplying by a negative reverses the inequality sign. We have n is greater than or equal to negative 65.